In this video, I'm going to begin with question number 15 on page 388. We are solving equations containing radicals. And again, we want to apply the IRS method, the isolate the radical first, then remove the radical, and then solve and check. So as you can see, I've gotten this started. We need to isolate this portion of the equation. So we need to take this minus 2x and bring it over to the right-hand side. You can see that's being done by inverse operations. And then we can lift that radical or remove the radical by squaring both sides. As we continue this process, we're going to see that we get 11x plus 3 on the left-hand side, and on the right-hand side we're going to square both the 2 and the x, and that's going to give us 4x squared. Whenever you have a second-degree equations, we're going to solve that using our methods for solving quadratics, and that gives us many different ways of doing so, but the first thing we need to do is get it into standard form. So that means getting everything over on one side and setting it equal to 0. So I'm going to bring the 11x and the 3 over to join the 4x squared, and when I do, I'd like to just again change sides if you wouldn't mind, giving me the 4x squared minus 11x minus 3 is equal to 0, and you can use the quadratic formula if you'd like, or you can solve by factoring. This is one of those tougher factoring questions because we have a leading coefficient that is not 1. We want the first two terms to multiply out to equal 4x squared, so I'm going to play around with this a little bit, and that gives me the 4x squared. Next, the second two terms need to multiply out to equal a negative 3. Now, I also need to get a negative 11 in the inside term, so I need to somehow get a pretty large number close to that 11, and I can do that if I put a 3 here because these outside terms will give me a 12. So as long as I have that, this will have to be a 1 to get that 3. Now again, we need a negative 3, so one of these terms has to be negative, and again, in order to get that middle term equal to a negative 11, I'm going to make that minus 3 negative and this a plus. And again, folks, this is just guessing and checking. Whatever doesn't work, you go back and try it again. Now we have two factors whose product is equal to 0, and we're going to apply the zero product property, which states if you multiply two numbers together and the answer is 0, then one of the numbers has to be 0. So in this case, x is going to equal negative 1/4 and x is going to equal 3. And now we need to go back up into the original equation and check to see if both of these work. I'm going to start with the easier one first, number 3, and when I multiply 11 times 3, I get 33. 33 plus 3 is 36, and we know that the square root of 36 is 6. So hang on to that for a minute. Then we're going to multiply 2 times 3 to get 6, and let's make sure 6 minus 6 equals 0, and so the 3 does check. Now let's check the negative 1/4. That's not such an easy answer. I'm going to have to write that one out. The 11 times negative 1/4 is going to give me negative 11/4. And I'm going to add 3, and then I'm supposed to subtract 2 times the negative 1/4, and that's supposed to give me a 0. Now, I know just by looking at this that this is negative 2 and 3/4. Negative 2 and 3/4. When I add a 3, negative 2 and 3/4, that gives me a positive 1/4. So I'm going to have a 1/4, square root of 1/4, and this is going to give me a plus 1/2, because 2 times negative 1/4 is 1/2, and that's supposed to give me 0. Now the square root of 1/4 is the same as the square root of 1 over the square root of 4, which is going to give me positive 1/2. And just by looking at this now, I can see that this is not going to add up to 0. So this number, this solution right here, wound up being what we call the extraneous solution. So we're going to disqualify it as our answer. I'm going to erase all this so I can do number 17. And number 17 is very similar. So let's just take a look and see what we can do with it. Again, what you've seen me do is isolate the radical part of this, and I'm going to bring this 5 over to the right hand side. Next, to lift that radical, I'm going to square both sides. It nicely lifts the radical off of the the left-hand side here. But on the right side, it almost created a bigger mess because we've got to FOIL this out. So in doing so, you can do this off to the side if you'd like, but you're going to get x squared plus 10x plus 25. Make sure that you FOIL this out, because if you don't, you're going to miss that plus 10x. Now, again, whenever you have a quadratic equation, you want to solve it using the methods that we've learned in previous chapters. So first thing we need to do is set the whole thing equal to 0. And so I'm going to bring the 3 and the 13 over to the right-hand side. So I'm going to subtract 3x and subtract 13. And my new equivalent equation is going to be x squared plus 7x plus 12 is equal to 0. And now this one is an easier factoring question by far. We're going to put x and x in the first position to get that x squared. And then we want factors of 12 that add up to 7. And this is pretty easy. It's going to be plus 4 plus 3. And it doesn't matter the order in which you put these. And the zero product property, again, if you multiply two numbers together and the answer is 0, one of these numbers has to be 0. So in this case, the number that would make this 0, x would equal -4. And in this case, it would be x is equal to -3. And now, once again, we need to go back up and check to make sure that these two solutions will give us proper solutions. So if we plug in a -4 here, we get a 12, or excuse me, a -12. We add 13, we get a 1. The square root of 1 is 1, so 1 minus 5 is -4. Let's hang on to that. We plugged in a -4, so when we take out this x and put a -4, the two sides do equal to each other. So -4 checked out. Now let's try -3. When we plug in -3, we get -9, and we're going to add 13. When we do so, we get a +4. The square root of 4 is 2. We're going to take 2 and we're going to subtract 5. That's going to give us a -3. And that's supposed to equal the value that we plugged in, which was -3. So those two solutions worked in this case. So both of those answers are correct solutions. Let's look at 19. Again, we went through that process of isolating the variable. Or excuse me, isolating the rational exponent this time. And we're ready to lift that rational exponent off, and again you take the reciprocal of that term, and what you do to one side you do the other. It nicely lifts off the rational exponent there on the left-hand side, excuse me, and what we get is x plus 3, because all of this disappears. And over here, once again, you've got to FOIL this out, and when you do, you're going to get x squared plus 2x plus 1. And once again, when you have a second degree equation, you got to solve it by some of the methods that we learned in the previous chapter. We could use quadratic formula every time if you're more comfortable with that than factoring. This gives us 0 here on the left, and over here on the right we're left with x squared plus x minus 2. And so this time, let's see if this is factorable. We can put x in that first position. We want factors of 2 that equal 1. That's pretty easy. The only factors of 2 are 1 and 2. To get that positive 1 on the inside, we want plus 2 minus 1. So again, it doesn't matter the order in which you place these in your parentheses. You get this. And then again, the zero product property states if you multiply two numbers by 0 and the answer is 0, then one of the numbers has to be 0. So in this case, x would equal -2 to make that a 0, and also 1. And now what we want to do is we want to check to see if both of these solutions will work. When I plug in a 1, 1 plus 3 is 4, and this means the square root, so the square root of 4 is 2. 2 minus 1 is 1, and it's supposed to equal the value that we plugged in, which was 1. So the 1 checked out. Let's check number 2. Remember, we're going to plug in -2, so over here is going to be -2 when we're finished. -2 plus 3 is 1. The square root of 1 is 1. And 1 minus 1 is 0. Oops, that didn't work, because we're supposed to get a -2 as a result of that. So -2 is disqualified. It's an extraneous solution. And our last question in this video will be number 21. As you can see, it's radical-radical, and when you have radical-radical, you want to get one radical on one side and the other on the other, and that's already been done in this problem, but some problems in the future may not be set up like this, ready to go. And again, to remove that radical, you want to square both sides. As a result, you're going to have 3x is equal to x plus 6, and really this can't get much easier. Going to subtract x from both sides. 2x is equal to 6, x is equal to 3. And once again, we do want to check to make sure that this is not an extraneous solution. So go back up to the original, plug that in. That gives us the square root of 9, and the square root of 9 is 3. And then we come over here, we get 3 plus 6, which is 9. The square root of 9 is also 3. So that is not an extraneous solution. That is a definite solution to this system. So that concludes this video.